Welcome back to linear algebra. Let's jump into Anki to begin with. Gonna have flashcards piling up, I can guarantee it. Alright, here we go. What is a matrix transformation? A matrix transformation is a transformation, it's a linear transformation that can be basically expressed as W equals AX, where W and X are column vectors, and A is a standard matrix. A transformation from Rn to Rm in the form of W equals Ax, where X is a vector in Rn and W is a vector in Rm. We have to do it again. What is a vector in Rn? A vector in Rn is it's an ordered n-tuple of real numbers. Nice. What does the notation TA colon Rn to Rm denote? Denotes a matrix transformation from Rn to Rm. Matrix transformation from Rn to Rm, in which the vectors are in column vector form and the vectors in Rm are obtained by multiplying Rn by an m by n matrix A. Alright. What is a transformation from Rn to Rm? A transformation, just in general, is a mapping of a vector in Rm to each of the vectors in Rn. A rule that associates a unique vector in Rm to each vector in Rn. What is the trivial solution of a homogeneous linear system in the unknowns x1, x2, xn? Trivial solution is where all the x's are equal to 0. What is the identity operator on Rn and how is it denoted? Identity operator on Rn basically is the matrix transformation in which the standard matrix is I. It's denoted T sub I. Yep. That's good enough. What is a matrix operator? Matrix operator is a transformation from Rn to Rn. A transformation from Rn to Rn in the form of W equals Ax, where X is a vector in Rn and W is a vector in Rn, and A is an n by n matrix. Okay, so say again, what are homogeneity and additivity properties of a matrix transformation TA? Homogeneity property, transformation applied to K times X equals K times transformation of X. And then additivity property of matrix transformations. T of u plus v equals T of u plus T of v for all. And for both of those, it's for all vectors that were denoted of the correct size and all scalars k. Okay. What is the difference between the comma delimited form and the column vector form of vector v and Rn? Comma is going to be like, comma delimited form is basically parentheses and then the values are separated by commas. Column vector is a column vector. Alright. What three basic algebraic operations can you perform on the equations of a linear system without altering the solution set? You can basically multiply an equation through by a non-zero number or constant. You can add a non-zero constant times a row to another row, and you can swap two rows or equations. What is the zero transformation from Rn to Rm, and how is it denoted? It's a transformation in which t of t of x equals 0 from Rn to Rm. That's how it's denoted. T sub 0. Transformation for Rn to Rm denoted T sub 0, for which T sub 0 x equals 0 for every matrix or vector in every vector x in Rn. What are the standard basis vectors in Rn? Okay, the first one is E sub 1 equals basically column vector 1, 0, 0, dot, 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 0. E2 equals 0, 1, 0, dot, 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 0. E sub n equals 0, 0, 0, 0, dot, 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 1. What does the notation x with an arrow TA over to W convey? Matrix transformation starting with x and resulting in W, basically W equals A times X. What is an operator on Rn? It's a rule that takes that transforms a rule that goes from Rn to Rn. Rule that associates a unique vector in Rn to each vector in Rn. What is a matrix transformation? A matrix transformation is a is this a rule that associates a matrix transformation that can be represented as W equals A times X, where X is a vector in Rn and W is a vector in Rm, and A is an n by m matrix. All right. What is a matrix operator? It's a rule that associates a vector in Rn with a vector in Rn. W equals Ax again, all that we just stated. Good. Transformation from Rn to Rm. A rule that associates a vector in Rm with each of the vectors in Rn. Rule associating a unique vector in Rm with each vector in Rn. What does notation TA, R, and Rm denote? Denotes a matrix transformation from Rn to Rm. What is an operator on Rn? It's a transformation from Rn to Rm, Rn to Rn. What was that? A rule that associates a vector in Rn to each of the vectors in Rn, I mean. All right. Okay. With all that, now let's recall what I did yesterday. We finished reading the chapter in 1.9, which is on composition of matrix transformations. Right, the inverse of a transformation. So how are they related? So the inverse of a transformation is equal to transformation A inverse of A. Transformation of A equals, the inverse of the transformation of A equals the transformation of the inverse of A. And these essentially cancel each other out if you compose them. If you compose them, they cancel out. So if TA, transformation A, if A is invertible, then we say that the transformation is invertible, right? Only if it's a matrix. So if a TA is a matrix operator and A is invertible, so it has to be an operator, we say TA is invertible. All right. That makes sense because A has to be squared to be invertible, right? I think so. All right, so what I'm going to do now is do one practice problem from this set, and then continue doing more Anki flashcards from 1.8. So talk to you in a bit. Okay, I finished one problem. This first problem from 1.9 was asking if two transformations commute. Not if they commute. Yeah, if they commute, meaning if you do one first or the other first, you're going to still end up at the same answer. This one was, the first transformation was reflect about the xy line y equals x, and then projected onto the x-axis. And so if we start here at the point, reflect over the x, y, and then project on the x. If we do it in the opposite order, project on the x, and then flip over, we see that these are the two ending spots, so therefore they do not commute. And then as far as Anki goes, I got another 7 flashcards done, so we got 9 more to do for 1.8. So that's it for today. Talk to you tomorrow. See you.